All right. Welcome, friends, to another episode of Spooky Software. I'm super excited about this particular episode because we're going to be talking about something very cool. We're going to be talking about Phoenix LiveView. So just for a little bit of context, if you're not familiar with what's going on here. So there's a programming language out there. It's called Elixir. Elixir is like maybe newish, last 10 years or so. But what's kind of special about Elixir is it runs on the Erlang virtual machine. So Erlang is actually maybe like 40 years old at this point, sometime in the 80s, I want to say. And what makes Erlang kind of special is this virtual machine that it runs on is called the Beam, B-E-A-M, and the Beam is particularly well suited for concurrent, sort of highly parallel tasks, right? So, in the same way you see programming languages like Go, which have kind of like green threads in Go, they're called Go routines. Erlang, the Erlang virtual machine has processes, right? And these are not like operating system processes. These are just kind of the Erlang term for kind of these lightweight threads that run on this virtual machine. And so all of these threads are completely isolated. They have their own memory space. They do garbage collection sort of independently. It's actually impossible to share anything because of this memory isolation. The virtual machine, it will sort of schedule and manage all these processes, make sure that fairness is sort of handled correctly. Sort of all these processes get equal time on the CPU and all these other things. You can kind of think of it like a little mini operating system inside of an operating system, because usually this virtual machine is running, maybe on Linux or something like this. There's a whole bunch of other advantages and things that these processes would provide for you, most notably how they isolate and kind of contain failure. So where I'm going with this is these processes, because they are so highly scalable, you can, for instance, have millions of them on a single machine pretty easily. They only take a couple kilobytes of memory each. The virtual machine is actually really capable of doing some kind of amazing things. Like, for instance, if you have a web server and you want to serve a request, it's actually sort of the de facto standard where every TCP connection that comes into the server will actually spawn a Erlang process, and that process will be sort of the process that runs for that particular connection. And so again, coming back to this idea of kind of isolation, and like if something goes wrong in that connection, only that process crashes, only that connection terminates. Sort of everybody else who's maybe using the server keeps right on going, right? And so because of that, because it's so easy to spawn processes in the Erlang virtual machine, this kind of leads way to some interesting architectures that I don't want to say were impossible, but sort of maybe outside the realm of conception for some other kinds of server software that we use. So Phoenix LiveView. So Phoenix is a framework not unlike maybe Rails or Django, something kind of in these veins, for dealing with HTTP and web servers, right? So it has built-in software for dealing with HTTP connections, posts, gets, query arguments, forms, controllers, JSON, all the kinds of things that you would probably want to do in a web server, even WebSocket connection kind of things as well. They have the Phoenix channels, for instance. But in the last couple of years, there's sort of been this library called Phoenix LiveView, which takes advantage of all these processes that the Erlang virtual machine is capable of spawning, and sort of these Phoenix primitives that I was just talking about, like channels and some others that we'll talk about later, where it enables us to write highly interactive and sort of live updating views, like HTML views, without writing a ton of JavaScript. So to sort of kind of compare LiveView to some common paradigms you see out there, I'm going to switch over here to my iPad, which I've drawn out some diagrams here with my beautiful, as usual, handwriting. But here on the top, this is an architecture diagram of sort of what I call classic web app, right? Which is, on the left here, we've got a browser and a server, right? And they're communicating over TCP. And so these first two lines are, the browser issues a HTTP GET request and the server responds with some HTML, right? And so the data that we're looking for, I'll actually show you an example of an application I wrote using LiveView. So the application does finance stuff. It's for like budgeting and it has transactions and categories and these kinds of things. So if we're talking about this finance app, the HTML that, I might be looking for would be like, a table with, transactions and rows and data, like how much each thing cost and what credit card was used and these kinds of things, right? And so all the data is encoded in HTML and the browser can display that, right? Maybe with some CSS and these other things. But for the most part, that's the general gist. And input, comes from these HTTP requests. So for instance, here on the bottom, these two right here, we might have a form and submitting that form might be, HTTP post, might contain some data that the server is going to use, process, send off to a database or whatever. And then again, respond with some more HTML. Perhaps they might even respond with some other HTTP primitive like, redirects or whatever. But for the most part, this is how sort of classic web apps work. And by the way, I'm going to refer to this as the classic or maybe the old school way to do things. But, I want to be clear that this is actually a great architecture. It's extremely well understood. Most apps probably work great with it. And you shouldn't be so dismissive of this, right? But these days, we're going to talk about a more modern approach, but not necessarily a better, is sort of a SPA driven or a script or a client driven app, right? And typically the way that this works is maybe the browser does some initial HTTP to grab some basically JavaScript, right? And maybe even the server that is sending this JavaScript isn't even like, a classic like dynamic server. It might be just like a CDN because these are static assets or whatever. But it takes this JavaScript and it runs an application. So inside the browser, right, like there's a JavaScript virtual machine. It's got state. It's maybe dealing with, frameworks like React or Angular or Vue or what have you. And there's a quote unquote only one, like a single page, because this kind of initial HTTP request is the only sort of classic request we ever really make. The HTML that comes down with it, it's like just enough to sort of get this JavaScript application sort of bootstrapped and running, but it doesn't contain any of the data that I'm looking for. It doesn't have any of the finance stuff necessarily, right? So what happens is because this JavaScript app is like running and it, has an active process, right? Maybe as you're using applications down here in the orange, you might make, sort of more HTTP requests to this dynamic server and grab probably more like JSON data, take that JSON data, and then use JavaScript to sort of update the page and make it look nice. And so you may also, I have here in green, you may also have some WebSocket connections for like maybe lower latency kind of updates or what have you. But in general, this is the kind of architecture you see. And I know that people get very fancy. They have maybe server-side rendered apps where, actually maybe this server here uses React in Node, right? And there's a Node process that it renders the initial page and all these other things. I'm sort of, that's sort of the more complicated version, but nonetheless, the idea is that we have this running process in the browser that has a bunch of JavaScript to do this, right? One of the advantages here, right, of this kind of client-side app, right, is they're highly interactive, right? So, because there's this process running inside the browser, this JavaScript application that's running, it can do things like add click handlers and, drag and drops and, has maybe like form validation, whereas I'm typing every single character, it can do sort of validation and show me quick and easy updates and, whatever. That's why people like this, right? One of the disadvantages, though, is I'm kind of writing two apps, right? Where, I not only have to write this server here on the right that, does, maybe permissioning and deals with like data encoding and deals with the database and all that stuff, but I also have to write this browser app over here on the right. It might even be like a separate repo. And so I'm kind of writing two applications, right? Whereas, back in this classical model, I really only need to write one. And certainly this one on the right, this server, is going to be bigger than this server down here. But the idea, hopefully, is that, this server up here on the right, this classical one, kind of the complexity and the amount of lines of code I have to write or whatever is like smaller than, this server down here on the right and this, browser app down here on the left, right? There are other disadvantages and advantages of these two approaches. I'm just kind of focusing on this one because this is kind of where Phoenix LiveView comes in. So this is where, so I made this one a little bit bigger. So Phoenix LiveView kind of starts like the classic, and then kind of ends like the second. So what I mean by that is, when you arrive on a Phoenix LiveView page, like let's say I go to my app and I request the index route, right? We will do a get, and the server will respond with some HTML, sort of in this classical way. That HTML will include all the data. We'll have a sort of a ready to paint application, has all the finance transactions and stuff in it that I'm looking for. And it also has a tiny, tiny bit of JavaScript, which I've put here in blue. And what's key about this amount of JavaScript is it doesn't scale with the amount of routes or features that my application has. Up here, every time I wanted to add a feature, I would like write more JavaScript and like more, React routes or whatever it is I'm doing, and handle that. Down here, this JavaScript right here is kind of the same JavaScript for all pages, right? And what that JavaScript does is, it's only a couple of kilobytes. What it basically does is when it initializes over here in the browser, it opens up a persistent WebSocket connection, which is right here. And you can see that the arrow I've drawn is bidirectional. And because just like we were talking about at the beginning of this video, the server is so good at spawning processes and can spawn really as many as it needs to. That's what these little green circles I've drawn here are, is each one of these persistent connections. So if we have 50 users using the website, we will have 50 processes, one for each of them. And that correlates to that persistent WebSocket connection. That will actually have its own state internally, right? And so as the user uses this browser app, they click things, they type in forms or whatever, they're going to send events over this WebSocket connection. And this is just transparent. You write your regular old view in the same way that you always did with classical apps. You just use server-side templates. But the HTML is slightly annotated with some click events and what have you. And those events come through, and then that process receives those events from this WebSocket connection, maybe make some state changes, and then it'll re-render the HTML to do the update, whatever it is, and then send that HTML over the WebSocket connection, right? And then this page over here, using that tiny, tiny bit of JavaScript, right, that opened up this WebSocket connection, can, sends these events and also receives this HTML and then updates the page. And again, you actually write very little JavaScript to do that. 99% of the code that you write will actually be on the server, which is basically this process that updates over time. And the good thing is this process is actually, for the most part, the same process that was used when this original HTTP GET came through. So I don't really write two processes, one for the WebSocket connection and one for the original HTTP GET. It's all the same logic. My template is the same. My logic is 99% the same or whatever between these two things. And this kind of WebSocket connection happening and this liveness of the view, if you will, is transparent to me as a developer. And I kind of still only write one app, right? And so this is really, really nice. It kind of like gives you some of the advantages here, but also some of the advantages here. It kind of bends the curve in this way. So this is really great for things like, client-side validation. Every keystroke or every time we submit the form, we can send some events up to the server. It can do the validation, send them back over this persistent WebSocket connection, and then like quickly and easily update the page with, maybe an alert banner or some errors or what have you. Now, I will say this won't work for everything. You could probably write some real-time games with it, no problem. Sort of silly things like, client-side validation or little clicks here and there, maybe navigating from page A to page B. So one of the things that we didn't describe here is maybe at some point, I don't want to necessarily update kind of the route I'm on. I actually want to change routes completely. Well, we might actually reuse a bunch of the page to do that. Maybe you have like a nav bar or a sidebar or whatever, and we really only want to kind of update the main content. This LiveView thing will do that great. And also, there's some kind of trickery involved in here, and this is all abstracted from you as a developer, where what we send over this WebSocket connection is actually really efficient. They did a good job here of the way in which the protocol that, again, is all transparent to you, that is sent over this wire, over this persistent connection, really kind of basically sends IDs of like, here's the place in the HTML I want you to update, and here's the data I want you to put in there. And it's usually pretty small. Not all the time, depends on what you're doing or whatever, but usually it doesn't even really have that much HTML in it. It might be just like, for instance, a new number, right? Maybe, as we'll see in a finance app, if I update some dollar amounts, maybe it'll just be the number that needs to change, right? Again, this is all transparent to you. So sort of to kind of prove that to you, I'm going to go back to my desktop here. So here I have this finance app that I've been telling you. This is open source, and I'll be sure to link the GitHub repo in the video description. But so let's look at like a transaction listing here. So this is the code. This module describes a view in the application where transactions are on the screen, and for a live view, the two most important functions you write are basically amount. This is kind of like an initializer, and it sets up some state, and then somewhere down here, which I may not even have in this particular view. Right, I don't even have one, but I will have. Listing live. That's the category one. I want to look at this guy. I will have some HTML, right? And this is a template. This is exactly the same kind of template I would write even if there weren't a live view here. This is a like kind of subset of Elixir called EXX, but essentially it's HTML and it kind of has dynamic places, right? And when I use LiveView, this is all transparent to me. Sort of Phoenix and this LiveView library kind of recognize the dynamic places in here. So for instance, it says, like here's an if, and what we show here is kind of dynamic. So as this process is running, this WebSocket connected process, maybe some state of like what categories are selected or whatever is changing. So I will change the text to none. Otherwise, I'll show how many are selected or whatever, right? These are the dynamic bits, and these are the bits that we'll be sending over the wire after that initial WebSocket connection is established. And that's really it. I just write this. It works just fine for both that initial HTTP request. I get like a fast loading first content paint, all that stuff. This also works without JavaScript, right? I can just send this HTML. The browser can display it, no problem. Even if the person has just JavaScript disabled, it just won't open this WebSocket connection, and that part won't work. You won't get any live updates, but you'll still kind of fall back to a working page without any extra work on your end. And I just want to also show so this is all of the JavaScript that I wrote for this entire application. It's 20 lines of code. So you import some Phoenix libraries, and this is honestly just a couple of kilobytes. There's some CSS. This thing is for like showing a loading indicator when I transition from page A to page B. I get basically a CRSF token for security. This is like for, establishing this loading bar. But the real thing that really happens is you make one of these live sockets, and then you connect. And that's it. It's this is kind of the meat and potatoes of this application is this library just opens up this connection. It has this protocol built in. It knows how to update HTML for you. So let's kind of demonstrate this running. So here we have my app running. Right, so it's got, transactions, and they have, dollar amounts or whatever. It looks like we spent $25 on coffee. So, I can kind of click this thing and, notice how I have interactive, like here's an error for like, I can't not have a description. Maybe if I write some weird funky number, like it says, that's not good or whatever. And to be clear, the JavaScript here is just the JavaScript to open this connection and receive these like live patch updates to the page and then update it this way. There's no React running. This validation is not done client side. What happens is every time I type a character, it sends a message up to the server. The server does the validation and it sends me a response, right? And I basically get this all for free. So one thing I want to show is that both of these, so maybe imagine two tabs or two different computers open. Real-time applications become like kind of straightforward and for free, right? So maybe I've decided that this coffee is not actually $25. That was a typo. It was just $2.50. When I save this, actually you notice that this other browser over here just automatically updates, and that's because each one of these browsers has its own persistent WebSocket connection. And each has its own persistent process, and they don't share any memory space. But on the server side, due to another Phoenix library called PubSub, both of those processes are subscribing to updates to transactions. So anytime any transaction is updated, all of the live views that are currently connected will get that update, and just automatically state will change, and the new data will come over the wire. So I can actually show you, by the way. We might as well look at the dev console because it is interesting. So if I refresh this, let's take a look at the network tab because I think it's kind of interesting. So if I look at all, you can see here I actually made a real HTTP GET request for the root thing, and the response does have HTML in it. It actually has content, and even if I had JavaScript disabled, I would still see all this beautiful transaction data, right? But notice that later at some point, I open up this WebSocket connection. Here's some images and script and whatever. You can see the total size of all the JavaScript is 100 kilobytes and only 25 kilobytes gzipped. This doesn't grow, right? So this includes, all that stuff. And as I add more features, this stays the same size. Notice how I have this WebSocket connection, right? And it's sending data. So I think green arrow is sent and red arrow is coming from the server. So for instance, if I update this from 275, if I say 95 instead, let's see what happens. You notice that there was some communication here, some heartbeat stuff, but at some point, actually, the server sent us some information. This is like basically some IDs of HTML. And again, I didn't write these IDs. These are just automatically generated for me by Phoenix and the LiveView templating. And it sent me some HTML. And it looks like it's actually sending me all of the rows and the tables and things that update to change this guy right here. And I imagine that actually this is not particularly great example of showing this off because it looks like it's sending a lot of things. Normally, LiveView is capable of distinguishing sort of the static bits from the dynamic bits and really only sending in the dynamic bits. I think what is happening is maybe because I'm not using like HTML IDs, LiveView isn't recognizing that these rows are actually not dynamic. In this case, it's a particular column within the row. But nonetheless, it still sent me the HTML that I needed to get the thing that I need to display. Yeah, so I mean that's really it. It's kind of you just write a normal sort of classical app and wire up this initial JavaScript that you write once, never change, and suddenly you have like a really interactive app. I don't think this is necessarily for every use case, but certainly a lot of web apps out there don't really need to do a whole lot. You definitely wouldn't be able to write something like an offline app. That this does require that persistent connection to get this interactivity. So something that works without an internet connection is not a good thing, or spotty internet is probably also not a good thing. I wouldn't want to do something that's like many updates. Like I probably wouldn't want to do animations necessarily. Maybe some kinds of real-time games could get away with it. Certainly, sort of your classic CRUD business-driven apps would love this kind of stuff. Anything real-time, again, when you have lots of people who are kind of looking at the same data, like imagine you had a stock ticker app or maybe a live updating transit app or something like this, would probably be great for this kind of thing. So anyway, I highly recommend you check this out. I kind of think that they're really onto something here. I do think that, maybe the API is a little bit immature of exactly how LiveView deals with like maybe componentizing parts of the view or how its optimization API works or whatever. I do think it's a little bit on the immature side. And to be fair, it's not even in 1.0 yet. I think it's like, 0.15 or something as of this recording. But I think it'll get there, especially with, maybe a little bit more community using it and sort of coming up with new ideas of how to make this API a little more straightforward and a little easier. And again, in some sense, it's already as straightforward as it's going to get. When we were talking through this diagram that I was showing earlier, and I can pull it up one more time, my server-side application is kind of the same exact app as I were going to write up here with a kind of basic Rails or Django or Phoenix non-LiveView. You just write templates. You have some state. That state updates over time, and automatically you get an interactive app. All right. Well, thank you for joining me for this episode of Spooky Software. I'm really excited about this. Again, I'll link the open source project. You can check it out. You can even use this to manage your finances should you choose to. Let me know what you think in the comments.